I am looking at a hypothesis test about the mean, and it looks like this is a left tail test because less than would be a left-tailed test. And so once we get working more of these, it does become important that you're going to see me draw these out so you have a normal curve. Remember that we're trying to see if the mean is 47.9, what would this test statistic be? And this test statistic we get by standardizing. So our mean gets standardized to 0, and then we have to figure out what this value is. And you might say, well, why did you put it to the left? Because this is a left tail test. So if I just simply plug in everything that they give me, that's the sample mean, which is X bar, 46.7, minus the population mean, 47.9, divided by the standard deviation, 4.54, over the square root of the sample size, 23. And pardon me, I had not typed this in my calculator yet. Be sure that when you put it in your calculator, you're putting that in parentheses and that in parentheses. So 47.9 divided by, open a parentheses, 4.54 over the square root of 23. Oops. And all right, and I get a negative 1.27 rounded, which makes sense that it should be negative, being left tail, and also that it is less than 0. Now, again, you can do these all day long by hand and probably run out of time on a test. So what I do, I go to Google Sheets. And so I look here, and if you watched the last video, that was a proportion, but this is going to be a t-distribution about a mean. And so I'm going to plug in my X bar, which was my sample mean, 46.7. The standard deviation was 4.54. In the sample size, 23. The null hypothesis was 47.9. This was a left tail test, and looky right there. There is my answer. If I cannot convince you to use Google Sheets by now, I'm hoping this module you definitely will be using Google Sheets.